So what we're going to do now is we're going to take a quick look at bending stress. And so what's happening inside the material when we're looking at that. So imagine here we have a diving board, and we have a guy who wants to dive off the diving board, and he weighs 200 pounds or so. So here's the dimensions of the diving board. And so take a look at this and think about what kind of stresses might be applied to this diving board as this guy is going to dive off it. Now the first thing you would think about is probably there would be some sort of shear stress, right? And you'd be right, there is, but that's not what we're looking at right now. We can look about that a little bit later. And you've looked about that some. But you can also imagine, and let's take a look at this, as this force is being applied, what's going to happen to the diving board? And it's going to bend, right? Thus the name bending stress. 200 pounds guy bending this material. So think about this. What's happening to this bottom face compared to what's happening to this top face? Look at the length. What is the length of this piece versus what is the length of this piece? And if you look at that, you know that, hey, this top face is going to be longer than this bottom face. And you know that the change of length in the material and the getting longer or shorter, that is associated with some sort of normal stress. So a quick review of normal stress. Up here we have compressive stress makes it get shorter. You're being compressed while the tensile stress is getting longer. So let's look at what's happening in this piece then. If we were to cut this piece and look at the face of that piece, what kind of stresses are being applied? And so if this thing is symmetrical, the original length is associated with the central line. The central line here is 5 feet, right? While this bottom line is maybe, I don't know, 4 foot 11 inches and a half or something. So I don't know how much it changes, but it's going to change some. And so as this force is being applied, this top face is going to start stretching. It's going to be in tension. And so we end up getting some sort of tensile stress on that top face, while on the bottom face is going to start compressing in response to that bending. And so we get some sort of compressive stress on that bottom face. And so the closer then you get to the center, the closer that stress ends up getting to zero. So you get stresses that look kind of like that. So it's like two triangles, like that type stress, and this top face is going to be in tension while that bottom face is in compression, right? So that makes sense. It's pretty simple, pretty easy to understand when you start looking at it that way. The equation that we use for that is sigma for our normal stress, right, is equal to mc over I. Now, I is your moment of inertia. Your c is dictates where you're trying to find the stress at. And so it's the distance from the centroid, which in this case is right there, your centroid to wherever you're trying to find the stress at. So if you're trying to find the stress at the top, trying to find the maximum tensile stress at the top, it's going to be that distance from the midpoint to the top. Now if you want to find the stress at the middle, we already know it's zero because we talked about that. The shape looks like that. And so right there at zero, there's going to be no stress. That C is zero, right? So there's going to be no stress at that centroid point. Cool. So let's find your compressive and tensile stresses then. Since this thing is symmetrical in this case, and it's not always the case, they will end up being zero. But let's do that real quick. Or they'll end up being equal to each other. So let's do that real quick. Our sigma for bending stress. Let's start with tensile is equal to our moment. Now moment, your M is for your moment, so let's find out what our moment is. We don't actually know what that is, do we? So what is our maximum moment going to be? So if you look at this piece, you know that this, using statics, let's draw a free body diagram right here. If this force is being applied, there has to be a reaction force, and there also has to be a reaction moment, keeping this thing from spinning, right? So there's going to be a moment right there. The maximum moment is going to be at this end. So let's figure out what that is. Our moment is equal to our 200 pounds times our distance of 5. So our M is equal to 200 times 5, which is 1,000 pound-feet. Now we do want this in our base units, right? So let's convert it, multiply this 1,000 by 12 to turn it into pound inches, which is what we want. So M then becomes 12,000 pound inches. Cool, we can deal with that. So our moment then is 12,000 pound inches multiplied by our C. Our C in this case, we want to go, let's look for the tensile first. So it's from this point up is 0.5. Cool. And our moment of inertia, since it's the face, we want the moment of inertia of this face right here. So that face that I just colored in. And so we use the equation 1 over 12 base times height cubed. Our base in this case is 12. And our height is 1, which actually comes out really nice and convenient, easy to calculate. So when we plug that all into the calculator, we end up with 6,000 psi. And that's our tensile bending stress. And we know that to be positive, and so that's good. Now, for our compressive stress, we know the compressive stress has to be negative on the bottom, and so we're going to say negative, whatever. All the numbers are the same because the moment's still the same. The only thing that really changes when finding compressive is possibly C, but in this case, since it's symmetrical, it's not going to change. So we're going to stick with 0.5, and we end up with a compressive stress of negative 6,000 psi. And so those are the basics of bending stress. It's not a hard concept to understand and look at. And so as you go forward, just remember how to use the equation. Remember the difference between compressive and tensile stress. You will probably want to know that stuff. So just remember those things and you should be fine.